In this section, we are going to talk about the beautiful planet Mercury. As you know, Mercury is the planet that is closest to the sun, and it's named for the Roman god that was a winged messenger. Here is an image of Mercury, and he typically had little wings on his feet. And the reason why this is a good name for this planet is because Mercury is the fastest of all of the planets. It has a tendency to move around the sun very, very quickly, and hence it is known for its swiftness. It's the smallest planet of all of them in our solar system based on size and mass, not of course including Pluto, which is smaller. And Mercury does not have a moon. This is a symbol that is used in old terms of alchemy for Mercury, and I always throw those in there because I think they're kind of interesting, and you do see them once in a while. Now, of all of the planets that are in our solar system, Mercury has the most eccentric or elliptical or oblong orbit. When Mercury is at perihelion, and you remember peppers are close to the ground, so perihelion, this is when it's closest, it's 0.3 astronomical units away from the sun. When it's at aphelion, at the apex of its orbit, it's about almost 0.5 astronomical units away. That is a good significant difference. That's about 30% further away at aphelion than perihelion. When you look at Mercury in the evening sky, it is very hard to see unless you know where to look and know what you're looking for. And that is because Mercury is so close to the sun. Its closeness to the sun means that you cannot see it in the middle of a dark night. You can only see it at sunrise and sunset, and typically the sky is still quite bright at the time that Mercury is visible. It's only about 0.4 astronomical units away, and that makes it kind of difficult to see. So you personally may not have observed Mercury very often just due to this position. One of the ways that we have a good view of Mercury and its companion, or our other planet, Venus, and that is when these planets go in transit. This is a word you need to know, transit. Transit occurs when a planet's path takes it across the sun. So the position of the Earth, we are in a position on planet Earth so that when we look at the sun, Mercury, let me draw a picture here. Here's the sun, here is Mercury, and here we are in Earth. So that we can actually, when we're looking this way, we see Mercury pass in front of the sun. Due to the fact that everything does not necessarily orbit in a flat plane of the ecliptic, there are slight angles to the orbits of all of the planets. We do not see Mercury and or Venus in transit every single year. Sometimes many, many, many years go by before we can see one or the other in transit. But when we see it, we get pictures like this, and it's quite beautiful. This is obviously kind of like a time-lapse photo, and it gives you an idea of how small Mercury is comparative to the very, very large size of the sun. One of the additional benefits of seeing a planet in transit is it allows us to give an idea of its size. How big is it compared to another planet like Venus and compared to the sun? This seeing something in transit is used very often as we're looking for exoplanets, these extrasolar planets around other suns. And we will talk a little bit more about that when we start going more into exoplanets, but this is a technique that is commonly used. Mercury's got a weird rotational velocity. It's very, very, very slowly rotating on its axis. Matter of fact, for a very long time in history, we thought Mercury did not rotate at all on its axis, but it rotates very slowly. One Mercury day, Earth is 59 Earth days, so that's right around 2 Earth months. That's the amount of time it takes little Mercury to rotate on its axis. Now, it's got a weird, crazy combination of days and Mercury years, because one Mercury year tends to be about 3 Earth months. And because of the combination of its days and months and years and how it orbits, it's a weird and crazy thing. It actually takes 176 Earth days, which is about 1/2 of one of our years, in order for Mercury to go through a complete sunrise and sunset. So if you were actually standing on Mercury, the sun would be up for you for about half a year, about 6 Earth months, and then the sun would be down and you would be in the dark for about 6 Earth months. And because of this weirdness, it affects temperature, it affects a lot of the features on planet Mercury. One of the big things that this weird day-night cycle affects is its extremes of hot and cold. A day on Mercury can get well over 800 degrees Fahrenheit, incredibly hot. Of course, also, Mercury is close to the sun, and so it gets a lot of direct solar heating, and that really is going to warm up Mercury tremendously during its day. When you are on the dark side of Mercury for, remember, about 6 months at a time, it can get very, very cold, about minus 279 Fahrenheit, incredibly cold. Weather temperatures on Earth, we seldom get below minus 40 Fahrenheit, at least where I live in Wisconsin. And so this is really, really, really cold. Very extremes of hot and cold, depending upon which side of the planet you're on. Mercury's composition is similar to Earth in the fact that it is made of a lot of rocks. It contains aluminum, silicon, oxygen bonded with these in a rock-type formation. It does have a solid iron core, but that solid iron core has a very weak magnetic field. The weakness of its magnetic field means that it is not strong enough to hold on to very much gas, and because it can't hold on to very much gas, it does not have much of an atmosphere. That, coupled with the fact that it is so close to the sun, the solar wind is going to blast like a blast furnace or a monster hairdryer the tiny atmosphere that Mercury has a long way away from that planet. There is a little bit of atmosphere there. It is 1 × 10⁻14 times less than we have on Earth. So I'm trying to give you a visual. If this is the Earth atmosphere, how much atmospheric pressure, the weight of the air on top of you, I cannot draw this small enough to possibly give you an accurate description of how thin the atmosphere is on Mercury. But there is a little bit of gas, hydrogen, helium, sodium, and if you know anything about chemistry, sodium is an incredibly corrosive, very lightweight metal, but it's actually a gas on Mercury, and of course a little bit of oxygen, but almost none at all. Surface of Mercury is interesting. It's very cratered, and you get an awful lot of cratering that has not changed if you have no perceptible atmosphere, because you have no weather. If you don't have any weather, there is nothing to kind of erode these craters. And you are familiar, of course, with lots of different pictures of craters on the moon. But one of the things that's really interesting is the craters on Mercury. Mercury's craters are softer. I don't know if that even makes sense, but they look like they've been sort of eroded. If you look at the moon, look how crisp these edges are. The craters are nice and crisp. You can see very distinct edges to all the different craters, large and small. When you get to Mercury, everything is a little bit blurry. And why is this? We're not 100% sure. One hypothesis is these craters were formed while Mercury was still more fluid, basically hotter. And that makes sense because of the fact that it is so incredibly close to the sun. One of the other things that is possible is that there might be slightly stronger gravity because of the small size of Mercury. I'm not 100% sure why this is, but it's just a very interesting feature. Some planets exhibit things that are called scarps. Scarp is a geologic term, and it means a ridge or line of cliffs. Now, this is actually a picture of a scarp on Mercury. This is a huge cliff that would extend, if it was on Earth, hundreds and hundreds and hundreds of miles. how the heck do you get something on a planet like this that does not appear to be terribly geologically active? One hypothesis is that at one point in time, Mercury was big, and slowly over time, it shrunk just a little bit, but its outer skin remained the same size. And so it kind of had extra skin. If you've ever seen pictures online, or you know someone who lost through a diet like 200 pounds, which means yay for them if they manage to do that. But people who do that end up with excess skin. Well, maybe that is the similar sort of thing with Mercury. When it was hot, it was kind of expanded a little bit like a hot air balloon. When it cooled, its outer skin was too big, and one bit of the skin sort of jutted over the other, and you get a scarp. Mercury is not the only planet that exhibits scarps. There are others as well. One of the cool things that was found by the Messenger spacecraft, which was a probe sent to Mercury, and this was only a handful of years ago, is the fact that there is actually ice at the poles of Mercury. Now, this is the hottest planet, and this planet is closest to the sun. How the heck do you end up with ice at Mercury's poles? These are actually photos, temperature-enhanced, computer-enhanced pictures of the poles of Mercury. And if you look at these temperature charts, especially for this photo, by the time you get down to the purples and the blues, you are talking about temperatures that are very, very cold, definitely below the freezing point of water. And at the poles of Mercury, see these blues and these purples? These blues and the purples at the poles indicate that there can be liquid water on this very hot planet. Incredibly amazing. Well, how in the heck can that happen? Two things. One, because of the fact that the light that is actually hitting the poles of Mercury is coming at such a direct angle from the sun. Here's the sun, here's Mercury, here is the sun. And when the light is hitting it, if there happens to be a little hollow, or it happens to be a little geologic dip, the stuff that is blocked by cliffs and hills actually gets no sunlight, and it can be very, 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 very cold. On planet Earth, temperature has a tendency to equalize because of the fact that we have air and we have an atmosphere. Well, if you do not have air or an atmosphere, temperatures cannot equalize, and you can get some nutty crazy hot spots. So this is one valley, okay, might be 100 miles across, and the bit that's in shadow is down near absolute zero. The part of the little dip or crater up here that is in sunlight is 550 Kelvin, and that is so incredibly hot that you would have molten lead. Absolutely crazy, but that is actually what was discovered in 2014 by the Messenger spacecraft. And just kind of an interesting thing, the reason why the probe was called Messenger, because it was going to Mercury, is Mercury, the god, was the winged messenger of the gods, hence its name. And that will do us for Mercury. We'll come back next time, and we're going to start with Venus. See you then.